This is Ray's Part 2, Ray's Rotary Magnetic Gates. This first section will cover input-output resistances. As a rotor comes up to the gate, many times it experiences a push backwards. That's called input resistance. After it fires through the gate, many times it'll lock up, or if it goes through, then it experiences a pulling force back towards, and that's called a output resistance. We're going to demonstrate this. I have a cut nail, put 3 neos on it, comes up, no pushing back and no pulling back. It's free to come through. Let's try two gates. Here again we approach, experiencing nothing but a pull. That looks good too. Now we're going to put 3 gates together. Go to the other side. And there again, it pulls through. Whoop, pulling back. Let's go from this side. This is where your firing is, but it pulls back. That's your output resistance. Even though one could not be detected, these small input-output resistances add up very quickly. We're approaching the gate, the rotor. The gate is approaching the rotor. Okay, it fires, but it pulls back. Okay, we'll go to the next section. This section is dealing with magnetic shields. I have 3 half by 1s, very strong at the ends, of course, magnetic forces. In the center where the north and south meet, this is called the neutral zone. It's covered in literature, but I don't think it's been really explored in depth. If we make another type of neutral zone using iron added to it, we can receive the same results. I have a north and a south. There again, the juncture point is the neutral zone. And of course at the ends, it's magnetic. Now we're making a plate, and see if we can make a neutral plate. A magnet on a piece of iron, you'd think, heck, that thing's gonna draw your metal any place on that plate now. But I turned the magnet so that the north is going one way, south going the other way. There again, I have a juncture point. That's the neutral zone. Of course, it kind of fans out a little bit. So the whole plate, instead of being really highly magnetic, is neutral. And even on the ends, on this side, if you get too close, of course it would. I've turned it so that one of the faces are facing the metal now. You see now it's magnetic. So that's something you should put in your notebooks, how to make a magnetic face like that. So we're going to use that approach in our next section. I've taken my horseshoe nail, people call it horseshoe nail, but it's really a cut nail, and I added a magnet there, producing a neutral zone here. just enough that I can get rid of and block that RN and R out. Okay. So we'll see if we can put our three together, which earlier had a high R out. It would actually, the resistance out was pulling back. So now I have a neutral zone on each side of my activator. I call this my activator bar. Now, because these are working as shields, they don't really fire. So it's really the middle one that does the firing and the work. Let's come up again. And you see, normally that would fire already, but because we're using them as shields, they don't. It waits until the middle one. So now it's free to go. It's almost like going to the turnpike, and every gate you come to, you have to pay a toll. Well, here, in essence, it's saying go ahead and go on through. You're paid for. So we'll go to the next section. So I made a bigger arrangement. There are different variations. I was just kind of experimenting. This one here, instead of having it on the end, I flopped it over. It seemed to help a little bit with the shielding. But if you notice, the end activator bars, shields, have the magnets, and the activator bar does not. It does the firing. So these are shields. So there again, we want to find out that we've drastically reduced the input resistance. So here we're approaching the gate. This is where the maximum amount of RN, I call it RN, resistance in, would show up. If it's out in here, I don't pay a lot of attention to it. It's very, very little, so far away from the other magnets that the magnitude that you're going to gain, but this one's pretty good. So that what we're trying to do is get more output than input. So I'm at the gate, so the input is basically just getting it to fire while we get a large output. The other requirement, we don't want to have resistance out or the pulling back effect. So if we're at the toll gate, we don't have to pay. They're saying go on ahead and go through the gate. So we're not pulling back. If there is, it's very, very small. It's not enough to pull against the small amount on a bearing. So here we're coming up to where it's firing the activator bar. You can see how it pushes. Fire it again. Up to the gate. Fires. I put another little one here. It just seemed to have a little bit of pullback earlier, so I dropped one there, and it seemed like eliminated it quite a bit. But it'll work without that. You might notice a little bit in there. There's a little bit. Just a shade. But here we go again. So if you noticed in part one, I was struggling to get through 3 of my gates. So this is definitely an improvement. They fire nice and evenly. I have these shields on front and back, so the activator firing bar, it can do its job and shoot it out there. So I'll be right back and end up with my magnetic cannon. These are the dimensions of my activator bars. There again, I was just experimenting different shapes and sizes. And the basic reason I did all this was so I could improve on the magnetic gates. The very important development was the magnetic V-gate. They would fire very nicely coming through here, but in between at each spot it would stop. So the gates, they had to pay to get through, so there wasn't a gain. It didn't work, but it was an important development. The important part of this is that you don't pay at the gates. You're able to freely go through. Okay? Here's my magnetic cannon. This is a Neo. This is a 3x2 1,000-pound pull-off. Very extreme. Of course, this video is just for educational and for enjoyment. If you work in anything with these magnets like this, it's your responsibility, of course. This is 8 inches by 2. So what I want to do is try and fire this thing, and I want to do it so I don't have any input resistance. So I'm going to keep away from it best I can, but get close enough so I can fire it. We fired it. We've got a half of a turn there. So if you had like a little motor here, that half cycle wouldn't have to be provided by the motor. So this would be like an assisted magnetic system. It doesn't provide free running, but there is definitely a gain in the energy that the motor would not need to be supplying. So I think this is really important. Fire one more time. Hope you've enjoyed this video and maybe got some other ideas. I encourage you, whatever you're working on, keep at it. I've literally had thousands of different designs on these magnets, going back years of experimentation. So I just kept at it. I would get discouraged, leave it, and then when I came back to it, it was a little bit fresher, I had a better viewpoint of it, and things made sense. So this will conclude this 2-part series of magnetic gates. Thank you very much.